Welcome to Amii. As one of Canada's preeminent centers of artificial intelligence, we thrive in our role bridging world-leading research and industry. Join us as we cultivate scientific excellence, develop talent, and coach businesses through AI adoption.
Hello and welcome to Machine Learning in the Real World, presented by the Alberta Machine Intelligence Institute. We are very excited to be here today as part of Calgary's annual Innovation Week. Before we get started, we do wish to acknowledge that the land on which we gather virtually today is the traditional territories of peoples of Treaty 7 in southern Alberta, which includes the Blackfoot Confederacy, as well as the Tsuut'ina First Nation, and the Stoney Nakoda. Calgary is also home to Métis Nation, Nation of Alberta, Region 3. As we are on YouTube today, feel free to post any questions or comments you have in the chat throughout the presentation, and we'll get to them if we have time during the presentation or definitely at the end. But to kick it off, we'd like to introduce ourselves. So my name is Adam. I'm the product owner of startups here at Amii.
And I'm James. I'm the machine learning scientist on the startup team.
And we're both very excited to be here presenting to you all today. So how do we think about AI and machine learning here at Amii? Well, this quote from Rich Sutton, our chief scientific advisor, does a really good job of summarizing it. So he says, it's the desire to understand the world, the desire to make tools, to make ourselves better. It's really totally human. The natural continuation of what humans are. I think that's really beautiful. Machine learning is a tool, and what do humans do if not build tools to improve our world? We are, at Amii, part of the Pan-Canadian AI strategy, which was launched in 2017, along with CFAR, Mila from Montreal, and the Vector Institute in Toronto. And at the start of the Pan-Canadian AI strategy, we were spun out of the University of Alberta as a not-for-profit. Amii is here to build internal AI capacity with industry and companies like yours. And we do that by playing the broker role between industry and academia, where we fund fundamental research and help translate the findings of that research into industry adoption. Here at Amii, we work to move companies along the 5 non-distinct stages of the ML adoption spectrum that you can see here. We work with companies to integrate AI and machine learning in a successful and sustainable way. It's within the implementing and operationalizing stages that organizations start to really gain a strong competitive advantage from AI. So now I'll turn it over to James to tell us a little bit about what machine learning is.
Thanks, Adam. So I'm going to talk about machine learning more from a holistic business process. Where does this fit into your business? So let's talk about some important example that you need an answer about. Maybe this is incoming email and you want to know if it's spam. Or maybe you have some machinery and you want to know how likely it's going to fail in the next week. Whatever this is, it's important to you right now. So this important example goes into some ML system, some black box. And out of this system is going to come some sort of helpful answer. And that answer might be that no, the email doesn't look like spam, or maybe that there's a 73% chance that your machine will fail next week or this week. So what is this box in the middle? Well, it's magic, or maybe not. Of course, this is actually a machine learning system, a QAM, as we often call it at Amii. Now, this isn't some industry standard term, but we've noticed that with so many different industries talking about a model, it's helpful to distinguish a machine learning model. So we call it a question answering machine, or a QAM. So I'm going to take this diagram here and rotate it, flip it up on its side to the side of the slide here, and talk a little bit about what the process is for building out the QAM. So in the end, we want to have this new data that's coming into the QAM and building an answer. And in order to do that, we need some learning data. And this learning data, it needs to be some big pile. How much you need depends on your application. Maybe you can get away with hundreds of examples. Maybe you need as many as millions, probably somewhere in between. But you're going to take this data, and you also want it to be as similar as possible to the new data. So if you eventually want to be able to recognize whether a photo contains a cat, you need to make sure that this learning data or training data has all sorts of different kinds of cats, different shapes and colors, different poses. You might also want to throw in a couple of dogs so the system identifies not cats. So once you have this big pile of learning data, that's going to help make the system more capable of handling different varieties of new data that comes in. So you throw this into a learning algorithm. And this algorithm is the thing that's going to take the data and somehow mathematically doing a bunch of, in my opinion, very cool and exciting science to build the QAM. And this QAM then is what you really want to be running in your business. So I'm going to draw a box around this central section of the diagram. This is the development phase. This is the phase where you build out the system that you're going to use. And then this next box, this is around the testing and production phase. When you see if the QAM is working, maybe if the testing is not good, you send it back to development. Otherwise, this is the QAM that's actually going to run and be useful for your business. But this on its own is not enough. So I'm going to grab this diagram, squish it down to the side of the slide, and together that's the science of machine learning. That gets me really excited. I love to see how all the math works out, and this is really interesting, but it's not enough. We also need to consider the other aspect, the business of machine learning. There's no point in investing in machine learning projects if there's not a business case for it. You need to get value out of it. So this process here, this involves some sort of human judgment that applies to whatever's coming out of the QAM. Like, what does the probability of rain need to be before you bring an umbrella? Is that at 20% or at 80%? And based on that judgment call of what the probability is, you're going to take some sort of action. In the case of an umbrella, the action is bringing an umbrella with me. And that leads to an outcome that matters in your business. With this probability of rain example, the outcome is me staying dry. In your business, this will be some other application. And all of this happens in the context of your specific business. So if you put these two aspects together, the science of ML and the business of ML, that together is the learning process for competitive advantage. And at Amii, we care about this a lot. We don't just want to do the science, though we love the science. And we don't just do the business part on its own because our expertise is that machine learning. We combine these two aspects together to really bring the competitive advantage. So now I'm going to hand things over to Adam to talk about some differences between AI, ML, and data science.
So we get asked all the time what the difference is between these three areas. And so how we really like to visually demonstrate the difference is through this Venn diagram here. So as you can see, artificial intelligence is a big encompassing field, and machine learning is a smaller field within that field of artificial intelligence. Data science, on the other hand, has a lot of overlap with both AI and machine learning, but also has pieces that are outside of both. And so really it comes down to AI is what we use to enable computers to be intelligent. Machine learning, being a subset of that, uses data, algorithms, and computation to enable machines to learn. And data science is really the process of making sense of data. So what can machine learning do? What can you use it for, and what is it currently being used for? So as James mentioned, machine learning can be a little bit mysterious. And I really find it easiest to think about it in terms of the tasks that machine learning is able to do for you. So these are the three main tasks that machine learning can do and support you and your business with. So that is predicting and class or value, identifying groups and outliers, and optimizing actions. Each of these areas is also referred to by a different name, so a more technical name that you might have heard before. So we often hear predicting a class or value referred to as supervised learning, identifying groups and outliers as unsupervised learning, and optimizing actions as reinforcement learning. So as I mentioned, these are the three major tasks that ML can help with, and we will go over each of these in detail throughout the presentation, including what they are, some examples of how they're being utilized right here in Alberta and in Calgary, and how sometimes they can fail. First, we're going to dive into supervised learning.
So supervised learning is the most commonly applied type of machine learning. If you're going to learn about one type, this is the one to focus on. And the basic idea is to predict a class or a value. And what I mean by that is, imagine that you have an image, like the one on the left here, and you want to ask, what class of animal is this, or what type of animal is this? And the machine learning system, the QAM, is going to say, oh, well, that's a bird. So we've identified a class. Alternatively, maybe I'm throwing in a picture to a system, but I want to ask, how much does this animal weigh? In this case, I'm trying to predict a value. And I might say, oh, well, it weighs 36 pounds. So these two are the basic ways how supervised learning is used to predict a class or predict a value. Oh, Adam, you're muted.
Classic unmute. So a really cool Calgary example is Sonata. And so Sonata is a clean tech startup that collaborates with desalination innovators across Europe, Australia, the Middle East, and North America. And they, together with those different organizations around the world, they share a goal of reducing energy and chemical use in desalination. Cleaning reverse osmosis membranes is critical to meeting daily production targets for desalination, all while avoiding the high cost of replacing membranes too early. So really deciding when to clean a plant is really important, and it currently relies too heavily on guesswork or generic guidelines. Sonata's patent-pending solution predicts the optimal time to clean. By predicting the best time to flush and clean, 6.2% more permeate was produced, all within the operating constraints, and projected membrane life could be doubled. That's really impressive. Another Alberta example is Meadow AI. So Meadow AI is a great example from, again, right here in Alberta that's using supervised learning to predict a class or value. Meadow has the world's first FDA-cleared AI platform that makes ultrasound workflow faster, more reliable, and accessible to all. Their platform is designed to seamlessly integrate with clinicians' workflow and drastically simplify both acquisition and interpretation of ultrasound images. The Meadow platform is vendor neutral and enables quick, objective, and reproducible workflows not possible with conventional methods. Right now, they have 4 products on their platform that include Meadow Hip, Meadow Thyroid, Meadow Lung, and Meadow Viewer. And one last example of supervised learning here in Alberta is Fredible. So Fredible is kind of like Siri, but for music, where you can play your instrument anywhere, anytime, and their expert AI will write the MIDI and sheet music for what you're playing. Fredible is available on the desktop or a web browser, or as an app for your smartphone and tablet, allowing you to write music wherever life takes you. You're able to harness the power of an expert music scribe and the creative power of 1,000 musicians in your back pocket. Now, what happens when these systems fail? So this example on the screen here is an example of a system that describes images, so what it's seeing in the image. The final sentence you can see at the bottom, a woman holding a camera in a crowd, describes the image actually quite well. So maybe it's not a fail. But if we dig a little bit deeper into how it got there, we can really see that the system has not understood the picture in the same way that we do at all. We can see that it identifies that there's a crowd in the back. You can see it labeled crowd. There's something purple in the image. There's a camera, and so on. But it also says that there's a cat in the kind of the middle right-hand side. which, I mean, maybe it was a little bit confusing for the system. It also then generates a few sentences about the image you can see. So first it's detecting words, and it came up with a woman, or we came up with woman, crowd, cat, camera, holding, and purple. But there are other ones. It's a woman holding a camera in the crowd. There is a purple camera with a woman holding a cat. Sentences that a human would definitely not come up with to describe this image. And so once the system, though, ranks these sentences, it arrives at the one describing this image quite well, and it does a pretty good job. But it's ignorant of the fact that it's working on, but step 2 is ignorant of the fact that it's working on keywords. And so the final sentence is actually picking up the word holding from the lady in the purple, or the person, sorry, in the purple jacket holding the camera. So even though it got the right sentence, it's pulling it from the wrong places, which is really interesting. And then another image captioning fail. We love examples like this. So on the left, the caption reads, "A cat sitting on a toilet in a bathroom." Okay, it's not really like any cats that I've seen before, or any toilets for that matter. And then clearly, as you can see, the image on the right is from Tony Hawk Pro Skater. I'm not sure what it's picking up there. A man riding a skateboard on a ramp. That's not really what we're seeing there. And so our point here is that machine intelligence is not human intelligence. Sometimes systems can fail miserably and hilariously like this here in ways that a human never would. And finally, one last example. Image captioning sometimes can pick up things that aren't there at all. So in this example here, the AI found a strong correlation between sheep and green hillsides. So as you can see here, it says that this pasture, it says a herd of sheep grazing on a lush green hillside. There are no sheep in this picture. I have zoomed in as far as I can, and there is not a single sheep here. So maybe it's that it's always associating that green lush sides and with images of sheep being on that, and that's why it's pulling it from there. But here it's clearly pulling something that is not at all here. All right, James, let's dive into unsupervised learning.
So unsupervised learning is also very commonly used by real companies. It's providing business value to these companies, and it can also have some unexpected outcomes. But first, what is it? Well, imagine you have a bunch of data. Maybe you can imagine this is a graph of like height versus weight, or two other variables that are very that can be grouped in clusters. So you can see that in this plot, some of these data points are obviously in groups, and some of these data points are far out from others. And this is pretty easy to visualize. It's just 2 dimensions of data. But imagine if we had 100 different data points. Then these convenient circles that a human could easily draw now become a lot harder to identify. And that's where the machine learning system gets really powerful, is that with 100-dimensional data, it can still figure out these groups of similar data points, clusters, and also the data points that are far away from anything else, the outliers. So what does that mean? How is this actually used? Well, Adam will talk about a couple of different examples of how this is actually useful.
Yeah, so a really cool Alberta example of using unsupervised learning is samdesk. Without any human intervention, samdesk's AI understands the meaning of social media posts, scores the uploader's credibility, and finally works to place these posts in space and time. In many cases, they're able to detect detect an event. The initial report, when they detect an event, the initial reports are from everyday people whose social posts are on their own and would not be enough to warrant a credible alert to their users. But depending on the authenticity, credibility of the person, and the quantity of posts about a similar event, they're able to actually bring that all together and corroborate or debunk an event happening. So you can think of Sam's real-time knowledge engine as your very own AI analyst who can distill real-world events into a credible stream of information. And in both cases, Sam's users are able to actually ensure the safety of people and know if a situation is safe to land an aircraft or monitor potential escalation for any required emergency deployments. This is happening all the time around the world every single day, where they're scanning through billions of social media posts. A local Calgary example is Ontopical. So Ontopical allows their clients to stay current on local government. Their system reads through thousands of agendas and watches thousands of minutes of government meetings every day, so you don't have to. Ontopical combs publicly available information from government departments, then processes and analyzes text and transcripts to deliver unique insights and give you access to the breadth of conversation happening in multiple governments every day so that their clients can be the first to know about new initiatives, upcoming RFPs, and more. And then a really fun example is Improbotics. So Improbotics is a tech-infused, inspired theater and comedy show with a live Turing test-based scientific experiment. An actual artificial intelligence-based chatbot is able to perform in the shows and tries to pass as human as it sends lines to one of the improvisers via an earpiece. Their impossible and hilarious challenge is to attempt to justify both physically and emotionally the AI-generated lines that sometimes make no sense at all. And I've personally seen Improbotics a few times, and it is hilarious. You definitely want to check it out if you're able to watch it. I know they've been doing some virtual shows during the pandemic, but once everything opens back up, if you can go check them out in person, I highly recommend it. It's a great time.
So here's an example of some interesting learning that doesn't always work out quite the way we would expect. So if you think about the question, screwdriver is to screw, as hammer is to, you're probably going to think a nail. Or if I say man is to king, as woman is to you're going to think queen. And you can actually break this down into some math. And you can get the AI or the machine learning system to learn the concept of different words. And then it can draw a line between these words. So you can say king minus the concept of man plus the concept of woman. And it turns out this actually gets really close to pointing to queen, to the point that you can train a machine learning system to answer these questions of analogies between different words. But sometimes it doesn't quite give the result you'd expect. Like, for example, if I ask you, man is to programmer as woman is to, well, you know what the answer should be. It's programmer, right? But if you ask the AI, it's going to say, well, man is to programmer as woman is to housewife. Ooh, bad AI. Don't do that. Well, the problem here is that the AI is learning based on human knowledge. It's learning based on past written word, whether it's scanning Reddit or Wikipedia or whatever books it can find. And it turns out that as humans, we have a lot of bias. And that bias gets encoded into our writing. And then it shows up when the AI learns, and it really doubles down on that bias. So you end up with this situation where the AI just assumes the gender bias that as a society, we're trying to correct. So it turns out there are actually methods that you can use to correct some of this bias. So there was a group that went back and to deal with this problem, they retained the male-female difference between like sister and brother or mother and father. They even kept the link between some more complex concepts like ovarian cancer and prostate cancer. But they removed the bias from gender-neutral words so that you could actually get that nurse or programmer or physician are not gendered terms. So even AI fails can sometimes be turned into successes if you just put a little more work into understanding what went wrong and fixing that bias. So next up is reinforcement learning. This is our third category. And when I put my scientist hat on, I love reinforcement learning. It's really exciting. This has a lot of potential to do a lot of really interesting things. It's a lot more challenging, a lot more difficult. We're less likely to recommend it to especially a company that's just getting started. But I'm going to tell you a bit about it because it's a really interesting area and it's good to know how it works. Plus, it has some really good failure cases. So if you think about that bug or that brain or microchip in the center of the diagram there, this is the AI, or the agent, as we tend to call it. And this agent will observe the state of the environment, and it actually gets placed in a dynamic environment where it's going to react to it. And based on what it sees about the environment it's in, it gets to take an action. It gets to do something in the world. And then we tell it whether it did a good job or a bad job, give it some kind of reward. And then we again give it an observation of the environment. And based on that, it gets to take another action. And over time, it learns how to do better things. Starts out really dumb, and over time can become very capable. So on this next slide, there's a video of a reinforcement learning agent that has learned how to walk, how to climb over obstacles. And in this case, this is one that's fairly successful. Obviously not a real world use case, but you can see how this agent, which was not programmed how to walk, it was able to move its limbs, but it didn't know what it meant to move its limbs. And so it learns how to jump over obstacles and do a whole bunch of complicated things. So some examples that we have of this, there's a project going on at the Drayton Valley water treatment plant to respond dynamically to the situation in the water treatment plant, to reduce power usage, to reduce the amount of chemicals that are used. This is important both for cost savings and for environmental impact in terms of chemicals in the water supply and the climate change impacts. And this is using reinforcement learning to learn what to do in this environment. Another example out of Alberta is the BLINC lab, which is using reinforcement learning for the control of prosthetic or bionic limbs. This is a better way to learn for a limb that only has limited input from the body. It doesn't have the rich sensory availability of what the nerves in a biological arm have. So instead, it uses reinforcement learning to dynamically interact where the arm is learning from the human and the human is learning from the arm, so that together they're really effective. But sometimes, of course, this doesn't work out so well. So imagine, similar to the walking example a few slides ago where there was a video, that we have, you can see in the top right corner, there's this cheetah. It's just this flat thing, and we hope that it learns how to move its legs to run as fast as possible across this checkerboard background. So let's see what happens, this thing that we've trained to run as fast as possible. I generally wouldn't suggest that a cheetah do the backstroke across dry ground, but this thing learned by accident at some point. It accidentally flipped over forward probably, and then flailed its legs and realized that actually gave it momentum to slide right across the floor. It's only about a third the speed of a proper run. It's not a good solution, but sometimes a reinforcement learning system is going to learn to do crazy things. Another example would be, in this case, this is like a boat race. And the goal is for the boat to do as fast laps as possible. So the developers who made this, they decided that the easiest way to teach it was to give it the reward of the number of points it's getting, right? Because the faster your lap is, the further you are ahead, the more points you get. What they didn't think of is that getting power-ups, the green things it's just driving through right now, those power-ups also give points. So the boat learned to just get power-ups in circles. And it's not winning the race, but it's getting a high score. So it thinks it's winning. And we call this a misspecified reward function, where we're rewarding it for something different than what we actually want it to do. So not a success case, but if we train better and if we avoid these mistakes, we can have effective real-world systems running in the real world. Next steps.
Awesome. So now how can you out there, you've seen what machine learning is, you've learned about the different types, what kind of tasks it can help you with, sometimes how the fails work, what's happening right here in Alberta, and you want to get involved with Amii, and how can you do that? Well, first of all, we have programming directly for startups. And so that's a team that both James and I work on. And right now we're recruiting for our Scale AI Supply Chain AI West program. And so this program is for startups who are building or plan to build AI and machine learning solutions that'll directly impact the supply chain. And so supply chain areas that impact include planning, sourcing, logistics, production, sales, and after sales. And the program runs 8 months, and we have a 4-week-long sprints as a part of that. And really our focus here is hands-on coaching and support to help you build your team's machine learning capacity. Applications are open right now, and you can book your discovery call with us right now as well. And I will make sure that that gets posted in the comments on the information for you in order to access that. And then we also have other programming that we've been working, James and I and Zhao on our team have been working very hard on over the past few months to launch. And so we're building programming and resources to support startups who are looking to either explore, build, and commercialize machine learning and AI technologies. So we have our machine learning exploration workshop, our problem mapping evaluation, and a membership program called Level Up that are all going to be available very soon in the new year. We've been working very hard building these programs out, piloting them, and constantly improving them as we move towards our public launch in the new year. So we're very excited to be able to bring that to all of you very soon. And other ways how you can get involved with Amii. So you can check out our 2020 impact report online. You can book a call with the startup team. And you can sign up for the Amii newsletter. So I'm going to drop a couple links again here for that. But with that, we would love to open the floor to any questions that anybody watching out there might have. Feel free to throw them in the comments and we can pull them up. And if you're thinking about a question, we'd also really encourage you to send some feedback. So feel free to scan the QR code here and send us some feedback on the session. We'd love to get any feedback about the session that you have, but we'll give it a couple minutes, see if anybody has any questions out there. There's got to be at least one. All right. Well, if there's no questions, we will wrap it up there. We really appreciate all of you taking the time to join us this afternoon. As I hope you've enjoyed Calgary Innovation Week so far. We look forward to chatting with you soon. If you have any interest in AI or machine learning, you can see my email on the screen there. Feel free to shoot me an email if you do have any questions or would like to chat. I'd love to chat with you. So with that, we will wrap it up. Thank you very much for joining us today, and we'll see you soon.